Actually, I think.
Okay, moving on, talking about our fixed pitch propellers, metal fixed pitch, to be more exact. So this is 0.3 way out here, not here, but out here, and that is resonant frequencies. There's just something I did mention before. Resonant frequencies. And that is a frequency set up throughout something that resonates with it in a bad way, actually. We talked a lot about that with the swinging pendulums, the counterweights on crankshaft engines. And so this sort of carries into that some metal propellers do have a tendency to get these really weird kind of frequencies that happen that are actually pretty bad. So metal props are subject to, this is not a good thing, they want them to go away, so they're subject to resonant frequencies. Resonant mechanical forces. Resonant mechanical forces may cause excessive vibrations. So mechanical forces may cause excessive vibration and may lead to the loss of the aircraft. And as I said before, that means that some engine propeller combinations have RPM limitations. RPM, everything's got an RPM limitation. So maybe I should say range. So it's more, because everything's got a red line, right? You can't go RPM, range. That's better. Range restrictions. All right, so example. It may say something like avoid continuous operation between, this example, 2,000 and 2,250 RPM. So you may see something placarded like that. Then you would also have something also on the tachometer. So it also may mandate the installation of a colored arc. A colored arc on the tack. And what it would do, you could have like a yellow arc. So a yellow arc for cautionary. Like it may allow you only to go to limit the amount of RPM that you can have for a period of time, like for takeoff or something like that. So takeoff. They say do not exceed this RPM for more than 2 minutes or something like that. Or it may have a red arc for critical vibration range. So you can't stay in that RPM range, you just go through it on the way up out of it. And then that was it. Let's see.
So would you not like be able to fly around wide open throttle?
Well, you don't anyway.
Just, or does it, well, yeah, but I'm like, in that instance, or does it just depend on what the combination says?
Depends on what the combination is. Sometimes, well, there's all these different combinations. Some aircraft are only allowed to do max RPM for a short period of time for takeoff, and that's takeoff only. Then you could have a max RPM for continuous operation. Some of them have a red arc just in the middle of the whole thing. Like, well, that's kind of weird. Why is this yellow arc right here, or red arc in the middle of everything? It's like you just can't be in there. You can go through it, but you can't stop in there. I don't actually have an airplane in mind that is that way, but I want to say that Stearman had that with their metal prop, but I don't remember, with the 220 on it. Most common.
I had a 170 with that Avcon conversion with the 0360 and constant speed prop, and it had one of those in there where it said don't fly between 2,000 and 2,200 RPM.
Okay. So was it a placard and an arc?
I can't remember the arc, but I know for sure right above the tack was the placard.
Okay.
The arc may have been there. I just don't remember.
So the most common failure associated with this condition, this resonant frequency that sets up, is a blade tip separation. So you get a blade tip depart light. So even a small piece of a blade tip leaving, I think, is going to set up a catastrophic failure because of the vibration then of the two blades that are not the same weight moving around.
When you say a small piece, what do you mean by small piece? Like size of a quarter, size of a grain of rice?
Dime or less? I think you'd notice a dime. I think you'd probably notice that quite a bit. I don't think a dime would be a catastrophic failure. Maybe even a quarter would be pretty uncomfortable.
Just land and put some Bondo in it, call it good.
Well, you're talking about composites. It's not far from that. So failure of the prop, hub and or blade. Hub and or blade. Retention feature, blade retention. You have to realize though, when you get into frequencies and imbalance and stuff like that, that was that IA renewal I went to, where they had the vibration analyst guys came and they talked about it. They talked about all these different frequencies, and I wrote it down in my notes somewhere. But the point that I would make off that was, without remembering the frequencies, there's frequencies you can feel, they make you uncomfortable. But there's frequencies that you can't feel, that don't bother you, that cause catastrophic damage to other things. Not that the ones that you can't feel don't wear out parts, but remember there are frequencies and vibrations that you as a human can't feel, and they do significant damage. All right, so I think, what else are we going to say about metal props? I think I get into maybe some repair. Most of the stuff you do repair, you do a lot of repair stuff out of the lab stuff. Oh, now I get into some repairs here, not too much. So, all right, talk about composite props. Now, your FAA Q&As and even your textbooks, they really haven't gotten into composite props. It's still kind of in this old school way of thinking that, they're just kind of the latest fad. I'm not going to worry about them. But I tell you, from what I'm seeing, what I'm reading, composite props, it's going to be the absolute wave of the future.
So they don't have carbon fiber?
Yeah.
Props? They do?
The absolute first composite prop that I ever saw was this one on the upper right, and that's an Ivo prop. And I don't even know if I have anything on here. No, I don't even have any notes. I had read some stuff. It wasn't worth putting in notes and stuff. But but it's a really fascinating design. I flew an airplane quite often that had one of these Ivo props. In fact, we have an Ivo prop at the hangar. It's on that little home built right by the your brake area. That one's set up for 2 blades. You can unbolt them and bolt another blade on, which is really kind of unique about them. And but the story behind it is this guy Ivan, I believe, because it's Ivo, it's Ivan, who defected out of Russia with this design. And I guess the guy is just brilliant. And there was this whole story behind it. I don't know this, I don't remember the story, but it was really, at the time, I thought it was the guy was pretty cool, who invented this propeller. And it's, like I said, the first composite thing I had ever seen and had been in use. And so there's actually a lot of them out there, and I've never heard anything bad about them. I wish I knew more about it, because I believe there's some component of being ground adjustable, but I just can't really see how it works. But I believe there is an element of being ground adjustable. And then you get into some of these other props. MT is the big maker right now of props. I don't even have an MT prop up here, I don't think. They're a wood core with fiberglass laminations over it, maybe some carbon fiber or something. Like I said, we haven't really gotten, the FA hasn't gotten into them too much, but I got some notes about the MT. The repair for these things is really bizarre. So things that you would see on a metal prop where you'd really just throw it away and say that's gone. These composite props, you can actually look at it and send the damage photos in for repair to MT, the manufacturer, and they'll send you back what to do. And some of the dimensions they have you take are just crazy. It's like, well, how far is it from this? How far does it go down this? What is the station here? And they get very exact, and they run it, I don't know, through some computer program. They'll spit it back, go, yeah, it's fine. Like, what do you mean it's fine? I'm missing a piece of prop. It's not a problem. And when I was at the IA renewal, they were showing us all these MT props that they had looked at and were in repair scenarios, and it's just nothing. And a lot of it is 5-minute epoxy. It's like, okay, you're fine. Just blend out the damage, 5-minute epoxy, you're good to go. So they're really a very robust prop, which I think is really cool. The funny thing about it is, though, and they did show some stuff where if you don't catch damage immediately and do something about it, they are prone to that damage growing to the point where the prop is, you have to throw it away or get a new blade. But even getting new blades, because these composites, they they have a metal hub or some type of hub, so the blades come off. And so the whole idea behind, I believe it was MT, is they have this thing called the master blade. And so anybody a prop shop that works with MT, you have to have this master blade. And so any repair you do to a blade, you have to balance it to the master blade. And so in theory, somebody could send you a blade. They don't even send you the whole prop. You fix the blade, you send it back, they put it on, and it's perfectly balanced. The prop shop that I was talking to, they're like, yeah, we're not doing that. Not doing a partial repair on a blade and sending it back to somebody else to install. And now you can think about the centrifugal force upon it and know why I agree with them. So, but yeah, 5-minute epoxy becomes your best friend on these things. So composite props, let's see, well, I originally had several companies are manufacturing composite props for certified or for home built, then I added certified. So several companies, several companies are now producing composite props for home built. And the first, like Ivo prop, that's strictly a home built prop for home built and certified aircraft. That picture that I showed you, I had up here a minute ago, I believe this is the Cessna Dreamcatcher. Does anybody know? It's Cessna's
Skycatcher, I think.
Skycatcher and Dreamcatcher. I'm thinking
165, I think it is their model number.
There you go. And it came out of the factory at the composite prop from Macaulay. Here's Hartzell. That's Hartzell's so the big manufacturers and props, it's just Macaulay and Hartzell. That's all that's left. for these really. And so you can see they both have their composite blades. Not only that, they're just cool looking.
That Cessna almost looks like it's a replica of the Cirrus, or trying to be the Cirrus.
Yeah, it's the I think it's the Revo. I think is what they look like. That's not the right word. I don't do a lot of these light sport airplanes. So I'm gonna talk about the MT prop because I think they're gonna be the big makers here. MT props. So with those, the material, and we have an MT prop on our 172 out there at the hangar, hand selected. This is the one I was talking about where the wood has to be in a certain region. Hand selected, multiple laminated, German ash. Very specific about that, ash wood. It is covered. So it's composite, but yeah, it's like, oh, wait a minute, is this a wood prop here? Covered by epoxy fiberglass. And sealed by a coating of acrylic polyurethane paint, and sealed by a coating of acrylic polyurethane paint.
I could only imagine the controlled environment that they build these in.
Oh yeah, when you start, yeah. Thankfully, we started with the stresses on it. Now you're thinking, whoa. So, the critical section, or I should say, the critical section of the leading edge, section of the leading edge, is protected by a bonded on stainless steel erosion sheath, I guess, protected by a bonded on stainless steel erosion. That's their word, erosion sheath. Slide this over. So I just pulled up MT's website. So that's what our prop, well, that's cool. I didn't mean to do that. Oh, I know what it did. It's a thing that moves. So I think that's a gorgeous prop. There, that's what ours looks like. So that's, here's your, well, actually can't see it, but your metal's actually out here. These are probably de-ice boots. I have no idea what I'm looking at. I'm just scrolling. Okay, sorry. I'll do that later.
Does icing affect composite props in a different way, or is it just still anti-ice boots, or with the liquid alcohol or the heater system?
I think it's the same thing, but you just got to be careful with heat. I think you have to be really careful with heat on these wood props. So, wow, they have an STC for a 152, but not the 150.
How much is the STC?
I don't know. So I was looking for. Can't figure it out. It just said they have it here.
Oh yeah, you probably got a call.
I'm not calling anybody. So I was looking if they made one for the 150, but they don't. So what do you got, Harry? 152 A through P.
Yeah, for 182 Quebec.
Oh, there we go.
There it is.
Oh, look at that. You need one of those.
You know, and I'm curious about that because, you know, there's a lot of hearsay that you hear at the airport, and one of them is something about 3 blades not as efficient as a 2 blade or something.
Yeah,
and I don't know anything about it, so I'm really looking forward to learning about it.
Oh, well, I'm going to disappoint you, but I don't know if I get too much into that, but I will tell you that what I have learned is the absolute most efficient propeller made, and I think I might have just crossed, let me see if I have a picture of it.
The single blade propeller?
Is the single blade prop, and I don't have a picture of it here. But they actually made one. Let me see. Come on, must have a picture. Nope, it's a single blade prop. I've been told that the 2 blade prop is a better cruise prop, but the 3 blade is a better climb prop. So it's outside of our realm here to get into that stuff. Yeah. Let me see, where am I at? So as far as these props go, what I've been told, 1, 2, right here. Well, I don't know, why is that 2? 15, 16. Oh, because it was material. Now it's 2 over here. 2. No vibration issues. Three bladed, I think, a little quieter, and they look cooler too.
Yeah, they look really cool.
Yeah. I think I'm going to leave it at that. I have notes about the Macaulay. All composite 2-blade fixed pitch propeller specifically designed for the Cessna 162 Skycatcher's Continental O200D. The propeller consists of a continuous fiber single piece design, giving it high strength as well as lightweight. It sounds like I took it off their website. Yeah, it's 5 foot 6 inches diameter, weighs just 9.3 pounds. That's 14.2 pounds less than the equivalent aluminum prop. So I go from 9.3, save 14 pounds up front, and then I had the Ivo prop, but we'll just leave that there. So let's talk a little about installation issues. Installation of props, because really, you're not going to design them, you're going to put them on. So, and I think we've talked about this quite a bit, but we're going to bring it back. So 3 types of crankshafts, you should know this. We have the flanged. We have the taper. We have the splined. All right, you know that. But we got to tie it into the propellers now. All right, so we've got the 3 types. We've got the flanged, and up at the top, I've got 2 flanged. The one on the left, because you can see some gray paint, you should know that this is a Lycoming flanged. And Lycoming is going to always put the starter ring gear assembly on top of it because it's got the starter mounts to the external down below. And so you got the starter teeth, they're going to go here. Plus you've got a V-belt drive in the back. And this also has the markings on it for timing the magnetos. This one over here is Continental. I can tell because it's a much smaller one. And it doesn't use the starter ring gear support because the starter is more integral to the engine and drives internal gears. They sometimes have the indexing pin, not always. Take a look at this one. Notice how it's not symmetrical. That is pushed down in. Usually there's a master one that has a fat lip around it, it's fatter than all the other ones. And you have to reference the service bolt to make sure you have the fat one there. What happens when you don't, well, this has indexing pins so that you only get the prop on in one way. And if you get the prop on in a weird way, it sets up harmonic balances inside the engine that are really bad. It's bad for the prop, bad for the engine. You can detune it, lose a crankshaft. So they put these indexing pins here on the bigger engines. Lycoming tends to use an indexing bushing. These bushings you can actually push in, push out, which you guys know or should know from your engines. And so you have to put the master bushing in the right spot. That is a little bit fatter than all the other ones. And it just so happens you follow the service bolt and then it'll tell you to, you know, exactly which position that fat one goes into. And then if you turn the propeller around, you'll notice that one hole of the propeller is just a little bit fatter than all the other ones. Well, what some mechanics do is they don't know how to put propellers on, and they accidentally put the prop on in the wrong spot so that this is the fat bushing, but yet the fat hole on the prop probably went over here. So that meant that the skinny hole was here. So as they tightened up the bolts on here to get the prop down, it pushed this bushing backwards and out the back of the prop. And so if you were to go back around, you would see that the bushing is pushed half out and it wasn't bolted on right. And they'll fly around that way for a couple of 100 hours before somebody finally realizes the prop's on wrong. So, tapered shafts have a big keyway that help install the adapter, but it doesn't index the prop. It just indexes the adapter. And then the adapter has 6 different ways it goes on. And we already talked about the master spline before. And then you have a hub that goes on that has a dead spline that fits over the master spline. So, and we did look at this slide a little bit ago. So if you have a taper crank, then you're going to put the hub on, which I believe we talked quite a bit about the hub when we talked about flanges and stuff. And I think it was probably Steven who stuck his fingers in and got blue all over him. Is that true?
Yep.
All right. How did I guess that? And I told you how to get it off, and it's a puller and all that kind of stuff. All right. So installation. So we have the 3 types of flanges. There are some, I believe, some Q&A questions. I know there's some test questions about some of this stuff, and you kind of have to. I'll do my best to explain it to you without you being there. So, all right, let's talk about the flanged. The flange type. So there are several different types of flanges and sizes of crankshaft. So I'll write that there. Are several types and sizes of flanges. Types and sizes of flanges. And by types and sizes, not only do you have you know, Lycoming versus Continental, which are completely and totally different, but even within one model of engine, you may have different ones. So it wasn't that long ago, somebody called me up and said, hey, I got a problem. I just overhauled the engine for our Cessna 152. That's a Lycoming engine with an 0235 L2C. And we put a new crankshaft in, but now our prop doesn't fit. I know, man, you got the wrong crankshaft with the wrong flange. And so, you know, I looked it up real quick through the service bulletins. I'm like, yeah, sure enough. And I called it back, said, yeah, definitely. There are 2 very specific, there's the A version and the B version of this crankshaft, and the L2C specifically for the 152s, you had to have this one. So you picked up an 0235 crank, not for an L2C, for a different model, and you have a different flange. And well, how do I fix that? Well, it's a simple fix. You just take the engine apart and put a new crankshaft in. And I hope I never forget this response. It was, well, can't I just drill new holes into my prop? Yeah, you can, I suppose, but you'll kill people. So I said, no, please don't do that. So I don't know what they did, but probably drill holes in this, who knows? All right, so typically there are bushings. There are bushings. Bushings pressed into the flange. That's more of a Lycoming thing, by the way. Pressed into the flange, which the prop bolts onto, which the prop bolts into. The smaller Continentals, they do that. Almost all Lycomings that don't have a spline shaft do that. The bigger Continentals, they just use nuts and bolts. You just have a big old self-locking nut on the back of most of those. The bushing may include, bushing may include a master bushing. Master bushing to prevent the prop, from being clocked incorrectly. Clocked incorrectly. Let's take a look at something. Made me think of something. Let's see. Oh, I shut down a PowerPoint when I shouldn't have.
So that's what they call when you mount the prop is it's being clocked on each of those bolts when you put it on the right spot.
Yep, it sure is. And I was just thinking that I think some of the PowerPoints that I have, they may even have the wrong. So yes, so it's, and you have a 2-blade on yours, Harry?
Yeah, 2 blades.
Okay. Oops, I'm pulling up something over here on my left. We'll go back to here. No. Oh, where's the one with the sky catcher? That's the one I wanted. There we go. Okay, this sky catcher, I can tell the prop's on correctly just by looking at it. It should stop in that position. Now, Harry, yours probably doesn't always stop in this position because you have a 6-cylinder. So sometimes it may stop this way. So
yeah, sometimes I think it's got a mind of its own, but I guess it kind of makes sense now that you say that with a 6-cylinder.
Yeah, 6-cylinder is going to be different, but this is a 4-cylinder. I can tell, and the 4-cylinder always stops this way. So on a 6-cylinder, I always follow the directions how to do it. The directions for a 4-cylinder are, the easiest way to explain it is you put the aircraft, or you put the engine on top dead center compression stroke, really of any cylinder. It doesn't matter because it's all the same. And then you put the prop on horizontal, and then you move it, then you take it off and move it 1 bolt hole backwards. And so this is top dead center. And the reason why I believe it started this way and they just never changed it, is if you have to hand prop this, you want to have it going, it's building up compression. So you want it so that it hits top dead center right. It's actually somewhere, yeah. So you're pulling it through, and then top dead center actually is going to be here. I'm sorry, it's going to be opposite that. So top dead center becomes the other way. So it stops here because it's coming up on compression. And so you'll bring it through, and the mags will click right here as it goes this way. So that's how you're going to put it on anyway. So just follow the directions on that. I just screwed it up. But it's never horizontal. It's never up and down. And it has to do with how it is for hand propping. Yeah, I wrote it down. Place the engine in top dead center, install the prop horizontal. Yeah, place the engine on top dead center, install the prop horizontal, then move in the direction of rotation 1 bolt hole. So that's why it stopped here. So if it was on top dead center, it'd be, it's not quite on top dead center yet. Top dead center, you got to bring that prop right to about here, be on top dead center. So it's starting compression. That's why it started there. So bring it on top dead center, and then you put it on horizontal, and you go 1 direction in the direction of rotation, and then there it is. But anyway, you got to make sure you put the prop on right. Otherwise, you get bad vibrations. Bushings, master bushing incorrectly. So incorrect installation. And I'm pretty sure yours, Harry, is indexed because it's a 6-cylinder and it's got counterweights on it. Incorrect installation can cause excessive vibration. Can cause excessive vibration. It's actually funny how many people fly around with their props on wrong. Incorrect installation. Can, oh, sorry, I'll put will. Not can, it will. Installation will allow prop to push out the master bushing. Push, that's a bad thing, out the master bushing. Which means the prop really isn't bolted on correctly at that time. So where and how do you go to put a prop on? Well, let me just tell you this. Install always install as per the airframe manufacturer's instructions, not the engine. I don't want to say not the prop, but as far as clocking and everything else goes, you install as per the airframe manufacturer's position. That's what I'm right, airframe manufacturer. Position. I'm going to change what I wrote here a little bit, just a little bit. And then I'm going to put this, I'm going to add a new line. I'm going to say this, torque per prop manufacturer. Manufacturer's instructions. So this is hypercritical. You think I got all excited about torquing cases together. This torquing props on makes torquing cases together look like nobody gives a crap. It is just so absolutely critical. In fact, it's critical to the point where most every prop shop that I ever worked with would send their props back and they would tape exactly what you were supposed to lubricate the bolts up with to the back of the propeller. And it's stickered and labeled to exactly how you are supposed to torque it. They wouldn't even give you a choice on this stuff. They're like, you know, one sticker says, hey, use this, and they would red tag it. They put a big old tag on it. They would say, caution, you will use the stuff that we just taped to the prop and torque it in accordance with this, which is exactly what we said on the sticker. Because if you don't, oh man, it ruins the prop. And I did see some pictures a couple weeks ago at that IA renewal of just all these destroyed props from mechanics torquing it on, and then the torque didn't set right. Number one, they didn't put the seal correctly in, so the prop wasn't tight against the flange. And as you're going to find out, there's a high pressure oil, 100 and some PSI running, or actually more than that, running through the prop core going up to the, the crankshaft core going up to the prop. And this mechanic was complaining, well, you know, my prop keeps leaking. And so they had them fly it in, and they didn't put it on, somebody else did. And they said, man, your prop is ready to just come off the front of your engine. It's not even touching the flange. You know, it's rocking back and forth. I think they had a picture of it rocking back and forth. It was horrific. So torque per the manufacturer's instructions. Now I messed up on my timeline. So I gotta mess that. So typical, I'll put this four-cylinder position. And I want you to know this because you're going to be installing a 4-cylinder prop on your test engine. And I do have instructions in there, but place engine. I was very specific here on number 1 cylinder. It doesn't matter which cylinder really. On TDC compression. Install prop horizontal. And then move in direction of rotation. The prop, not the engine, because that doesn't do you any good. And then move prop, I'll put that prop in direction of rotation, 1 bolt hole. And then install. And then, like I said, I believe that was, then that goes back to the hand propping. Oh yeah. Oops, that'd be 10 now, 10. Don't forget. I'm gonna try and spell it so you can read it. Don't forget the spinner bulkhead. And I write that just as, because oftentimes the spinner bulkhead goes on first, then the prop goes on next. And then sometimes the forward bulkhead goes on. And I've seen so many mechanics, they just get so excited to get the prop on, they get it torqued, they get it all safety wired. You spend a good half hour doing that. And then they go to put the spinner on, they realize that all the bulkheads are still sitting on the bench. I'm like, oh, dang it. So they have to start all over again. And half the time they're wondering why the bolts were too long too. Why do I suddenly need a bunch of washers? Torque in proper pattern. Don't just do one, then the next, and the next. You got to do that star pattern. Safety with 040 is what SenseNiche wants you to use. And 041 is what Macaulay says to use. So I just keep some 041 in my box and everybody gets 041. All right, C. What if you have a taper crank? Taper crank. All right, so if you have the taper crank, you're going to use the adapter hubs. That uses adapter hub. And you know, the adapter hub taper crank, that's just lower horsepower engines. Well, I love it when I say something and look down, that's actually my next note. It's found on older low horsepower engines. And I know we talked about this before, but I'll say it here. Installation fit needs to be checked. Fit needs to be checked. What do we use to check that there with, Stephen?
Blue dye.
Install Prussian blue. Prussian blue to clean, slide dry crank. So remember, you put this Prussian blue all over the crank, and the formula was something like only take half of what you need, throw the other half away, and now you have twice as much as you should have. So then you install the hub and torque with key in place. That's the with the key in place. That's the shear key that goes in there. And then remove hub and inspect ink transfer to the hub.
Like 30 minutes to get off your hands.
Minimum contact area. Anybody remember? 70%. Nobody remembers. That's all right. 70%. If it's less than 70, then I'll put that if less than 70%. Clean and lap surfaces. Clean and lap surfaces. All right, this is very important now. Once you are satisfied, remove the ink. And always, always, always install with anti-seize. If you don't install anti-seize with anti-seize, and I am the next person that has to take it off, I will come and find you and ask you why you did not use anti-seize. Install, torque, wow. And safety, prop. Well, hub and prop, really.
Hey, Kevin.
Yeah?
So since you torque it twice, does that mean you use 2 sets of bolts or hardware?
Okay, so remember when you put the hub on, we're talking about the hub, you just torque it with this big nut right here. So this is the nut you
Okay.
torque it on. Okay, then you're going to take it off and inspect everything. Then you're going to torque it back on and you're going to safety it through these holes right here. You're going to put a pin from the inside right here out, and it's going to go through that hole right there. And that's how it's torqued and safetied. And remember I told you it was like 100 and some pound man or something with 5 hammer reps. That was for the big Stearman. So anyway, you're going to, there's the bolt right there. It's actually, that one's put in backwards. It goes from the inside out, so centrifugal force holds it. I'm looking in there and I can see a bolt with the nut coming through. So this one's backwards, sorry. And then remember, your bolts have to go backwards. So your prop goes on, you put it in top dead center, compression, put it on horizontal, then move it 1 bolt hole. So it's going like this. It's, what position is that? That's like the 1 and 8 position, somewhere around there. And then you put the bolt on, the prop on, and this type of prop, especially the wood ones, because the torque is so low, you're always going to have castellated nuts with cotter pins. Then, oh yeah, this is going to be another one of those things. Okay, then we have the spline shaft. Spline shaft. Spline shaft has its own issues here. Used on higher horsepower engines. All right, so often includes a master spline, which is 2 splines missing a valley, 2 splines missing a valley. Hey, look at that. It's almost time to go. Or a screw in the valley. So it makes the valley unusable. So I think that's probably a pretty good place to stop. Probably spline shaft is a good place to stop. I went right by it. So, wow, tomorrow's Friday. Right? Am I right about that?
Yes, sir.
Yeah.
Yep.
So, and then we, I don't know, it's looking like we're going to be done next week. So that's for sure. One way or another. So, all right, you guys have a good night.
All right.
Right, you too.